Thanks for bearing with me, everyone. So yeah, like Wendy said, the title of my talk is Magic Method Metaphors, Understanding the Python Data Model. This is kind of another developer talk. I am a developer here at CIC and a PhD student. So my plan is that whenever I'm not forced to, I'm gonna alternate between kind of a developer talk and then kind of more of a research-based talk. So yeah, I guess I already introduced myself. So a fun fact about myself though is that I love nerdy things. And in my presentation, I'm gonna get to show off one of the nerdiest things I could possibly show off. And that is a terminal plotting library written in Python. And it's a lot of fun, but we're mainly gonna be using it as an analogous way to show off different parts of the Python data model. So a quick acknowledgement to James Powell. If you have never watched this talk on YouTube, it's about 2 hours long, but it's called So You Want to Be a Python Data Expert, or a Python Expert. It's an amazing talk. It's probably my favorite Python talk ever. James is an amazing speaker. If I'm able to do just a tiny bit of that today, I'll be very pleased with myself. It's a very practical talk, which is what I try and model my talks on, and it's the inspiration for this talk and a couple others like it, so please check it out. In terms of an agenda, we just did the introduction. A lot of this is going to kind of be some background, and then we're going to jump into a demo. But before we do any of this, we're going to play some Python trivia. So first up, x equals to 1, y equals to 2, print x plus y. That is going to be 3. We're good. We're doing well. Next, if we have x is equal to 1, y is equal to 2, print x minus y. Obviously, -1. No surprises there. Let's ramp it up a little bit. List 1 plus list 2, print x, y. What do we get? We get list 1, 2. Okay, that makes sense. Next, if we do list 1 times 2, what do we get? We get list 1, 1. So this is kind of interesting. We can start to do operations on different data types, even though they're not the same type. But what happens if we start to do other things? So if we're looking at sets, for example, if we take the set 1, 2 minus the set 2, 3, we get the set difference. So that would just be set 1, right? And if we do this one more time, if we say set 1, 2 plus set 2, 3, we're obviously going to get the union, which would be set 1, 2, 3, except we get a type error. We get unsupported operands for the plus operator on 2 set types. So this kind of goes against what we would probably expect to happen. And the correct operator for this is actually going to be the OR operator, kind of like Boolean. So if we do that now, we get what we would expect of this 1, 2, and 3. So if we keep going along, we can play this game where even if we do this with dictionaries, which is something kind of a little more complex, if we have x with the keys a equals to 2, b equals to 2, and then we have another dictionary with the keys a equals to 1, c equal to 3, we do the same kind of ORing operation. What do we get? We get the dictionary a equal to 1, b equal to 2, c equal to 3, where the first dictionary value of a at 2 is overwritten, the second key at a equal to 1. So these are kind of more easy ones, but this is probably one that you've never seen before, or at least some of you haven't seen before. If we are working with NumPy and we have 2 NumPy arrays where we have an array of 1, 2, and we have a second array of 3, 4, we do print x at y. Anyone care to venture what this operator does, what it means?
Multiplication, automatic.
Yeah, matrix multiplication. So this is a very kind of unfamiliar one. It's not really in the standard library so much, but it does come up and it's something that you can define, and I'll show you a way to kind of work with this in your own way later. So very good, very good. You win the trivia. So we would get a equals to 11. There's one more though, it's called path. So if we import from this path library, we can make a path object, and let's say that we set it to /etc, which would be a file path in Linux. If we then use a true division operator on x, and we use that along with a string, that's kind of a strange thing to do. Usually if we're working with paths, they're strings and we're just kind of concatenating strings. But what does it mean to true divide an operator? Like, what does this mean, right? So we can kind of conceptualize this in terms of when we're actually typing out a file path, we might literally type out a slash. So here it's not being used in the sense of it being a true division operator, it's being used in the sense of it as a slash. So we would get kind of this POSIX path is what we would expect. So okay, good job. For those of you who knew all of this, that's awesome. But for those of you who didn't, you might be saying, okay, well, where do I find out more about this? Because some of these things are strange, and if I had 2 sets and I added them together, I would expect those things to give me the union of both sets. Like, why are all these things happening? So it turns out all of this is very well defined in this thing called the Python data model. And it's defined right in the documentation, if I can pull it up. I don't know where it's gone. Oh, I guess it's over here now. It's in the Python data model. So we can see this is documentation directly from Python, and it's quite extensive. So I'm not going to go through all of this with you here today, but just to know that that's where you could go for more references if you wished. So just know that in Python, objects are Python's abstraction for data. All data in Python are represented as objects or by relationships between objects. So as much as it pains me to say, Python is in fact an object-oriented language. So I could go on for another 2 hours and talk about all the little tiny little pieces of this, but I kind of want to get this moving and get into the demo. But the next part of this would be the classes. So that's what we're going to be focusing on today. And classes are callable. These objects normally act as factories for new instances of themselves. But variations are possible for class types that override something that we're going to call a dunder method. So this would be dunder new. And if that is complete and utter gibberish to you, that's okay. It sounds quite strange to me, and you could go on for 5 hours more and read through the documentation. But just in the simplest sense, we can think of it as the following, where if we had a blueprint for how to build a house, we could take that blueprint and then go build a bunch of houses, right? And we can see here we have 4 houses, and they all have 3 windows, they have 1 door and a gate, right? So that's common between all of these things. But we can understand that even though they reference the same blueprint, different attributes and functionality of them might be slightly different, right? So the color on the house might be different, or the little thing above the door might be a little different. So those things can change. I don't know precisely when this happened, but a long time ago, some really crazy people got loose into the world, and they thought it would be a good idea to start making chains of these blueprints together, known as inheritance. This kind of betrays how I think about inheritance, but just know that it's something that's there, and if you're an undergraduate student and you're learning about this for the first time from your professor, it undoubtedly will kind of feel like this, where they're just trying to say, oh, there's all these relationships, and it's a lot to learn. But just know that we're not going to be focusing on these kind of deeper relationships between objects today. We're instead just going to be thinking about it as one kind of object that we're going to modify along the way to do things that we want. So don't fret, is all I'm trying to say. But in the simplest form, we're going to think about these things that we make as classes, right? And we're going to think of them as dictionaries. So for example, whenever we do c.x, if we have some kind of class in Python, that's actually the exact same as if we said c._, which is the convention for dunder, dunder dict, to get the dictionary of the key at the value x. Those are equivalent. So classes are also special. They have special attributes, i.e. like a doc, like a dunder doc attribute that you can use to get the documentation for a given class or a given function. And they also have special methods, and these are the things that we're going to be focusing on here today, such as dunder add, and we'll get into what this actually, what it does and why it's important. So let's actually jump into one of the demos. So really quickly, if we have a class, right, I guess my first question to you is, will this run if I just have this class called dog and I don't do anything in it and I just say pass? Give you a moment to think about it. We think maybe it'll blow up, but turns out it'll actually just run just fine. So if we say Python class py, it turns out it executes just fine because these are both statements in Python. There's nothing wrong about that. We can also say the following. We could say dog is equal to a new dog. And then we can start to give the dog some attributes, right? So we can say dog.name is equal to Lucky, right? And this would be analogous to when we're painting our houses. If we're referencing the top level blueprint, in terms of it being a different house color, we can say that this might be like a different name of a thing that we're looking at. So for example, now we can say if we wanted to print out the name of this object, we can see that it will print out Lucky. So that's great. And I'll actually close this just to show you that it's executed. We can also start to add some functions. So if we set dog.bark equal to a function, work, and then we say dog.work or bark. If we want to print out and see that it's a function before we call it, we can do that. So we can see that we've added a function now to this class. But if we actually want to call it, we can do so, and it will print out work. So that's great. But what is missing? Why is this kind of strange? Like, we usually don't do this in Python, even though I'm showing you this example. And you're probably thinking, what about this? What about the init? What about the kind of initialization for all of this? This is typically what we do in object-oriented programming languages, like where is it, why is it missing? So when we do this, we actually use one of these special methods, and it's called init, right? And when we do this, it lets us do what we were doing when we said dog.name is equal to Lucky, but we actually just start passing this in, so we can say is equal to name. So we're going to pass name in whenever we instantialize one of these objects. So now we can say self name is equal to name. Okay, and if we do this now, if we run this, this will blow up in our face because we actually haven't specified what the name is going to be. But if we go back and we now move this to our dog, then it will work, and it can still say work. We can also add some more things like that function itself. So we can say bark, work, and we can start moving things that previously would have been outside of our class into our class. But most importantly, I want you to think that when we were using our special method or our dunder init, we're trying to define some kind of behavior that we want our class to do. And this also might be a little strange to think about, but what other behaviors might we have access to? So if we just print out dog, we just print out the object, we'll see that we get this thing. It says main.dog object at a given address, and it's this kind of representation for what this object is going to be. Well, we can actually change this. We actually have full ability through Python, through these special methods or these dunder methods, to change it. So if we wanted to, we could reference one called repr, and this just stands for representation. And all this will do is it will return a string that we want whenever we call print on this object. So for example, if we wanted to say self.name, reference this thing's name, because that's something we might want to know whenever we print this object out, we can say print dog, and now it will say Lucky, right? So that's something that we've changed, right? Print is just something that's in the Python language, and now we're kind of manipulating our object to fit in with this. But we can print anything, right? Like we can print strings, and we get to define what it means for this object to be printed by changing these kind of dunder methods. So just another really quick one, if we wanted to, we could specify one called len, or the length. So for example, return self.age. So if we wanted to add an age for our dog, if we wanted to say age, then if we added the age here to 10 and we printed this out, it would still say dog. But what if we wanted to get the length of a dog? Like, what does that even mean? You might be thinking, like, you want the literal length of this dog. No, that's not what I'm talking about. I'm just talking about, for example, if we have other data types like a list and there's 10 elements in this list, we might want to know, okay, there's 10 elements in this list. But if we're talking about more abstract things, we might want to define what it means to get the length of this thing. So for example, if we call len on this dog now, we can see that it's going to be 10. And again, remember that len is just something that's part of the Python ecosystem, right? You can call len on anything, just like you can call print on anything. You can call print on len, for example. So that's just a very, very quick intro to some of the ways we're going to use these dunder methods. But now I want to jump into this, this library called plot text. So for reference, this is a terminal plotting library. It has quite a few stars, not as many as that other library I was talking about last time called Fire, but it's still probably one of my favorite things. It's going to be getting an update at the end of the month, so I'm very excited for that. I know you all are too. So yeah, I'm just going to see what the next slide is. Okay, that'll be the class. So what actually is this? It basically is the terminal version of matplotlib. If you've ever used matplotlib to make plots for all of your papers, this is going to be something that's very similar. I like this mainly because it's very fast and it's lightweight, and you don't have to have like a graphical user environment. So if you're on the GPU and you're just on the command line, you can get a plot from all this data and not have to worry about managing or saving off all these small images. So at the very start, we're just going to initialize some of the plotting code. So we'll just give this a moment to run. And then now if we look at some list that is going to be the sign, sign function for math, obviously, applied to a range of numbers, we're going to plot this, and we're going to plot it in the terminal. So when we do that, we'll see this kind of plot on the left-hand side here. So that's nice, but just look at this. We can see, oh, okay, I have to remember to do all this initialization with the plot, and I have to put the data in there, and then I have to remember some of the keyword arguments about the marker and the color, and a lot of things I have to manage. What if I'm there and I just want to be like in a flow state? I don't want to have to go over to Google and remember all this stuff. I just want it to be there, so I just want to say, hey, print plot data. That's it. I don't want to have to think about anything else. So that's what we're going to work towards slowly. If we keep going down, we can also start to add other pieces of information. So if we had this sign plot, we can also just add a range of data. So if we have Z, we can also replot both of these things. But now we have this problem, right? If we look at the plot, we see there's like one little green speck at the bottom, and that was our previous plot. So this is a problem because we actually want to see what this might be doing. And it's very common that we might want to plot these things on different axes. So in order to do that, we might actually say the same thing as we did up above, except here we might actually specify, hey, I want this particular plot to be on this axis side, and I want it to be on this Y side, for example. So now if we replot this, we can see that, hey, look, our sign kind of function is back. And this isn't the most high fidelity thing of all time. We're not trying to get like the actual most continuous value ever. This is just a very quick visualization, almost even to confirm if we even want to go through the effort of plotting this in the first place, because sometimes it can be expensive. So that's one way we can get around this. Another way is just if we wanted to separate these plots out. And this gets a little more involved. I hate doing this, to be honest, in Matplotlib, where you have to go and say, oh, I want this kind of grid of subplots, and oh, I want to select into this particular one, and then I want to plot it this way. And it just gets a little more involved. If you like doing it, that's totally cool. But I know for myself, if I have to do this, we can see that we can separate it out. But it's a little bit of work. I would much rather say, hey, plot minus plot if I wanted it to be underneath, or plot plus plot if I wanted them to be beside. I don't need to know all the details. I just need to recall some of that higher order behavior that we were previously talking about. Like if we were to print something, we get to define what it means to print something. If we're going to take the length of something, we get to define what it means to take the length of something. Same thing here. If we wanted to add two plots together, we get to define what that means. So let's start doing that. Let's just say that we took all this plotting code and we moved it into a class, just to start. And let's just say that we had the most simplest form of whatever this would be, where we take in some data using that init method that we talked about earlier. We would set some of the initial data values, and then we might say, hey, plot this value. And note that this won't actually show us anything, but a really good modality for understanding what it means to plot something is literally just to print it, right? Usually we're gonna say, hey, plot.show, with calling that as an attribute function. But now we can actually just say print the plot of the range. So if we wanted to, I'm actually going to close this and put it full screen. So now if we wanted to, we can just say, hey, plot this and put it full screen. And note that everything here is what you really would be doing in real life. So you wouldn't be seeing a lot of this library code. All you know is that you would have some kind of range and that you would say print plot range. And that's all you would ever have to think about. You wouldn't have to think about anything else. So okay, what happens if we start to increase the complexity of what's happening? Right before we do that, just like we defined repr earlier of what it means to print something, the dunder method for string or the double underscore, it does the same thing. So if we start to jump down to adding on to this a little bit, we can start to add on another dunder method called call. And essentially all this will do is take your class, turn it into a little function. And there won't be any way for Python to distinguish between these two things. You'll be able to call it just like it's a function. And this is important because sometimes maybe you want to pass some information into it right when you're initializing it right away. Sometimes you might want to pass some more information into it later. And you don't really need to know the difference between those two things. Just know that they're happening during that time. So if we run this, now we can see that there's two ranges that we've passed to plot. There's this first range, and then there's this second range. And if we print this now, we can see that we now have two plots. And we haven't really had to do all this like, oh, plot.show, like make it this marker and color and whatever. It's just very quick and say print plot data twice. That's all we've done now. So okay, let's start to extend this a little bit more. So let's just say that that we want to move the data into an attribute called plots. And you'll see why we're going to do this in a moment. It seems counterintuitive. But now whenever we add data through the init method or we add data through the call method, all we're going to do is actually call the call method. So this is a little strange when we say self calling itself with this datum. We can say that it's just going to call itself with the call method. I know that's kind of a little bit of a mind warp, but once you understand it, you'll understand a little bit of what this self-referential thing is a little differently. And for reference, that's I think it's the this keyword in Java, but correct me if I'm wrong. So okay, if we do this now, we'll see it's the same thing, but we've just changed it just ever so slightly. It gives us the same plot, or it doesn't give us the same plot because the data is off a little bit. So let's fix that. So we'll see that gives us the same plot. But let's say that we had this, right, and it was giving us this problem we had earlier where we had that little green speck at the bottom and this big red line. We actually want to see both of these kind of full screen. So how might we do that now using the modalities that we talked about? So one of the ways that we can do that is with the OR operator. So the way that we're going to use this dunder method is we're going to say double underscore OR, and we're going to pass in self, and then we're going to pass in an other. And what this means is that when it's called, it's going to append its data to its self plots. I know there's a lot more details in here, and we're going kind of fast, but just know that the only thing that changes is that we're defining what kind of side it's going to go on as part of its arguments. So the most important part of all of this is that we get to say, hey, we're going to set variable p equal to a plot of a range 10, and then we get to say p or range 10 reversed. So now when we plot this, we can say, hey, plot it, and it goes back to what it was, right? But even more simply, if we wanted to, we could potentially extend this. We could say range 10 and make a marker and then say plot, and then say range 10 to 0 minus 1. So this would potentially give us the same thing, which is quite interesting because it fits our mental model of like, I want this data on the right-hand side of the plot and I want this data on the left-hand side of the plot, and just do it. Don't ask me about all this like dot calling and dot plotting and stuff like this. But the problem is when we do this, we're actually going to see that it blows up, and it's going to say unsupported operand types for range and plot, almost like what we saw before for the set error with when we added them. So how do we fix this? This is kind of strange. It should be working, right? But it turns out that we actually have to define another dunder method in order for this to work. And this would actually be the r/or the right-hand sided or. So this is a little more advanced, and essentially this is called whenever there's differing types or the self object that's being called is actually existing on the right-hand side and the other thing is existing on the left-hand side. So now if we do this, we just add that very small piece of code. The thing that we showed before is running. So now I don't have to think, again, this is the only thing I would have to see in my code, is just to say, hey, print this range of 10, XOR, or with a plot, or with the other range. And I would know that this data is going to be on the left-hand side. I would know this data is going to be on the right-hand side. So okay, that's pretty neat. We actually just fixed that problem earlier of just putting things on the left or the right-hand side. And we don't have to do it without any effort. I'm sure I would never have to remember any of these crazy plotting methods again. It'll just be, oh yeah, what's that thing I coded up like 2 months ago? Oh, it's probably the or. Yeah, boom, it works. And then I'm off to the races, right? So, okay, let's keep extending this a little bit more. How am I doing on time with you? We're there?
5 minutes.
Oh, okay. Yeah, I guess I'll show you two really, really cool ones. I guess the next one would just be if we add some way to control the subplots so that we can add a couple other methods. So all this would look like is if we changed our print statement a little bit to control for the subplots, and we defined two more dunder methods, add and sub. We can actually start to add and subtract plots. So if we have a plot x and we have a plot y and we have a plot z, we can say x plus y. And now when we run this, we'll see that they'll be side by side. But we can also say x plus y minus z, right? And now we can say, okay, now it's split down. And we can just do this forever, right? Like we could say like plus x minus y plus z. And we'll start to get these really crazy things. But note that this is happening in one line, right? Like we didn't have to type, like if you had to do this in Matplotlib, you'd probably go a little crazy being like, oh, I have to access this part and I have to remember what coordinate system it's in. Here it's just very simple. Oh yeah, I want this extra thing. It's very, very low cost. So okay, what's the last kind of crazy thing we can do? Well, we can also start to tap into things called get items. So this is a very special method, or a dunder method in Python, that actually allows you to define what it means to access that object at a particular index. So for example, if you're ever using PyTorch and you have to make a data loader, you actually have to define this. It won't run unless you do. And that's because as you're looping through the different batch sizes, you have to specify this index, and you have to say what it means for a for loop to access a particular index of this data loader. So here, all we're kind of saying is when we access this plot at a particular index, it's going to call the string method at that index. And the string method in this case has been a little bit perturbed, but just know that if we go to do this, this is really cool. If I go a little bit over time, just give me a moment. So if we say plot range 10, and then we access this at 4, and we print this, we can see that it gives us the range to 4. It doesn't give us the range to 10, right? And we can also say, okay, well, what if we give this at 8? We can see now we get up to 8. So we've actually started to define what it means to access a part of a plot. We've defined what it means to add plots and subtract plots. There's crazier things you can do. Something else I did was you can divide a plot by a certain value if you want to shrink it. So you can start playing with the size of the plots. But probably the funnest one is because we can access it at a particular index, we can actually start to access it in a loop and actually print it out over and over again. So here, if we define a plot and we start to specify a couple ranges inside of it, and we also add on another plot that's a sine range, and we put this in a loop, we can actually start to print out these things like in real time. So it's kind of like a little bit of a modality that you can start to access. And this completely blew my mind when you could start putting these little Lego pieces together and defining for what you want a plot to be. So I know like I couldn't go over all of the code. I just mainly wanted to open your eyes to what these dunder methods can do for you if you want to apply them in a very creative way to reduce, I guess, the amount of mental overhead that you might need to stay in a flow state while you're doing research or something else. So with that, I would say main takeaways are that you can define your own metaphors here. It's a very important part of the language. This isn't just like some weird little thing that I did to show you how some plots work. This is a very core part of the language, and you can apply them to a very wide range of scenarios, not just plots. It's whatever you want this crazy object to do, you can define that. So with that, thank you so much for listening to my presentation. I hope you enjoyed it.
Thank you, Griffin. Any questions?
Yeah, we're moving pretty fast. Yeah.
Thank you for the presentation. Regardless of the fact that when you use dunder methods, you can actually use symbols for Go to make it easier. Is there any other significant other than, because you can write it in other methods, you can name the methods, and you name it exactly what you want.
Yeah, so for example, a way that you would get around the big error kind of that we saw earlier is if we go to the set, the plussing of the sets. Turns out that this is probably a bad idea. I don't know why they didn't make the plus operator the union. That just makes sense to me. But yeah, you're right. You should, if you're doing this to be clear to others for really important things, you should say x dot like union y as like the call, because that's actually what it's doing behind the scenes. Is that plus thing is going to call out to that other function, or the OR operator is going to call out to that other function. So that's definitely how you should do it if you're doing it like for real. But if you just want to make like your own thing and you don't want to have to remember a lot of stuff to just do it fast, you can do that. But no, that's great point, great question. Behind all of these methods, again, if we kind of go back to, where is it? Back to this. Whenever you see a plus operator, it's calling these dunder methods behind the scene. So you can always kind of put those back if you wanted to. So if we were here, we wanted to say like A plus B, that's literally equivalent to if we said A dot dunder add B. Like that's actually what's happening. You could write that and it would run. Yeah.
so it's operator overloading.
Yeah.
Okay.
Yeah. Well, it's not just operator overloading, because there's other things, right? Like when we access like a particular index, we get to define what that means. There's other things too. If any of you are familiar with context managers, whenever you want to make one of your own, you have to define an enter and an exit method. And in that case, it's acting almost like a generator, but you get to define what it means for it to go into a particular thing, do some setup code, do some more stuff, and then exit. So a timer, for example, right? So it's not just for operators, it's for using like the with statement when you open a file. Like that's what some of this does behind the scenes. Yeah, or in a loop like we just saw. It's implicitly calling that get item method.
Okay, since we are running out of time, thank you very
Yeah,
much, Griffin.
thank you.
You can find the library and